वेलकम बैक टू माय चैनल बीके टेक। तो आज हम पढ़ने वाले बीएफएस एल्गोरिदम के बारे में। इसे लेवल वाइज ट्रैवर्सल एल्गोरिदम भी बोलते हैं। इफ आई टॉक अबाउट द बीएफएस एल्गोरिदम, सो बीएफएस एल्गोरिदम इन डेटा स्ट्रक्चर, it is a graph traversal algorithm that starts traversing the graph from the root node and explore the its neighbors node. Then it selects the nearest node and explore the other all unexplored node. So if I explain you this, basically what happen is that we are given with the one level 0 node. Basically in every question you will be given a starting node. So in this case you can consider that this is a node is a starting node. Then it comes and see its in the its adjacent list, that what are the adjacent of A. So in this you can see that B, C and D nodes are the adjacent of A. So here what it does is that then it contacts B, then it after contacting B, then it contacts C, then it contact D. So basically they are doing a traversal based on levels. First it contacted the level A node, then it contacted the all the nodes which are present on the level 1, B, C and D. Then after that, all the unexplored node of like E, F, G, H, E, F and G, H of the level 2 will be explored. So this traversal technique works on the based on the level. So and main important is the starting node. So like if you will be given the starting node as D, then it will consider D as a level 0 node, and then it will consider A as a level 1, because immediate adjacent of the it is A is the immediate adjacent of the D, and H is also will be considered as a level 1. So in the respective manner then the graph will work. Now we are going to move toward the initial configuration of required for the BFS algorithm. So we require one queue which will be the first in first out manner. Then we are going to require a one visited array, which will be having a size of the number of nodes plus 1. Number of nodes plus 1 because we are using a graph which is based on the one based indexing. Then we will be provided with the one starting node. Once the starting node is provided to us, we are going to put that into the queue and mark it as a visited. Once this is done, we will start uh, taking out the elements from the queue. So we are having a one element into the queue, we take out the one from it and put this into the answer list. Once this is done, we are going to check that who are the adjacent of one in the adjacency list which is provided to us. So if you see, there are 2 and 6 which are the adjacent to the uh, our first node. So we are going to put them into the queue. So the 2 will be put it into the queue and marked it as a visited. Then 6 will be put it into the queue and marked it as a visited. We are doing this because BFS is a level wise traversing algorithm. So once this is done, we are going to take out 2 from the queue and put it into the answer list. And then we are going to check who are the adjacent of 2. And if you see, 3 and 4 are the next levels of 2, and they are adjacent of 2 also. So then we are going to put both of them into the queue and mark them as a visited. Once the both of them are put it into the queue and marked visited, then we are going to move toward the 6, which is the next element into the queue, and which was the adjacent of the 1. So we are going to next take out the 6 and put it into the answer list. Once this 6 is taken out, we are going to check who are the adjacent of 6. So if you see, 7 and 9 are the adjacent of 6. So 7 and 9 are adjacent, so we are going to put both of them into the queue. So 7 will be put into the queue and marked visited, then 9 will be put it into the queue and marked visited. Once both of them are marked visited, we can say that the level 2 is all the nodes of the level 2 are visited. And once this is visited, now we are going to take next element out of the uh, our queue, which is 3, and put it into the answer list. Once this is done, then we are going to check who are the adjacent of 3. So if you see, there are no adjacent for 3. So we are going to move toward the next element, which is our 4. So if you see, once after putting the 4 into the answer list, you can see there are only one adjacent element, which is 5. So you will find out 5 and then put this into the queue and mark it as a visited. Once this is done, then you are going to move towards the next element, which is 7. So and put this 7 into the answer list. Once this 7 is put into the answer list, you again will check for the adjacent elements for the 7, which is 8, and mark it as a visited. So now if you see, all the nodes are marked visited, and and we have visited, but we have not traversed all the elements. So we are not going to stop here. We are going to move toward all the other. So and check. So now we are going to take out the 9, and we will put this into the answer. So if you see, 9 is not having any adjacent element, so we are going to then move toward the 5, and similarly in the same manner we are going to move toward the 8. So and put this into the our answer list. So basically, the answer of our BFS will be the same in the same in the manner which we have taken out our elements from the queue. So 1, 2, 6, 3, 4, 7, 9, 5, 8 will be the answer for our BFS algorithm. Now let's come to the coding part of this. So here is a GFG BFS problem. So here we are given with the starting node as a 0, and it's a left to right graph. So let's define one queue in this, which is of integer type. Then we will define one visited array, which is of a boolean type. And it will be of v plus 1 size, number of node plus 1. Then we will define one answer array, which is of integer type. You can name it as BFS. Then we are going to add our 0th element into the queue and mark it as visited. Then we will traverse our queue until it gets empty. Then we will retrieve the element from the queue, and it will be retrieved in the variable node. So queue dot poll I am going to use, which is going to retrieve the element from queue, as well as it will delete, and then this element will be put it into the our answer array. Then what we will do is that we will apply a for each loop in the element which is retrieved from the queue, and check its neighbor in the adjacent list. Once this for each loop is ready, we will check if this neighbors are already visited or not. If they are not visited, then we will visit the if condition. In if condition, we will put this into the queue, and we will mark this as a visited. Once this BFS implementation is done, we are going to return our answer array. So here you can see we get the expected output. Now you can submit it. So all the test cases are passed. Thank you for joining.